Hello to all my viewers. This is Dr. Dhaval Maheta, and let's discuss how to run one-way ANOVA in Jamovi. In my previous video, we had discussed one sample t-test where we are comparing the sample mean with the population mean. Our null hypothesis in this case is there is no significant difference between the population mean and the sample mean. Then we had also discussed the independent sample t-test where we are comparing the means of two groups. These two groups are completely different. Section A with section B, process A with process B. Our null hypothesis in this scenario is there is no significant difference in means of two groups. In case of dependent sample t-test, the same respondent is compared before and after the treatment. Null hypothesis is there is no significant difference in means and before and after the treatment. Now, when we talk about ANOVA, it's a case where we are comparing more than two groups. You can see all these three groups are different. Say, for example, this is group A, group B, and group C. My null hypothesis will be there is no significant difference in marks of more than two groups. Alternatively, it's a little bit tricky. There is a significant difference in mean marks of at least one pair. See, A compared with B, B compared with C, and A compared with C. Even if the difference in the mean marks is significant in at least one pair, then also your ANOVA will become significant. And that's the reason in case of one-way ANOVA, our alternative hypothesis is there is significant difference in mean marks of at least one pair. Now, which test to run completely depends on the variances of the group. That is, variances in the groups are equal or not. So the first question is, are variances equal according to the homogeneity of variance test? Yes. If your p-value is more than 0.05, then you will run Fisher's ANOVA. And if you get the p-value less than 0.05, it means that there is a significant difference in the group, then you will go for the post hoc test, which is known as a Tukey's test. Similarly, if the variances are not equal, say for example, p-value less than 0.05, then you will go for Welch test. And here, if your p-value is less than 0.05, you will run post hoc Games-Howell test. Let us see how we can do this in Jamovi. Now, I'm having this employee data. I'll request all my viewers to kindly refer my previous video to understand the flow of this lecture series. So, my target variable is here salary. And I want to compare the mean salary according to the job category, which is clerical, custodial, and managerial. What will be my research hypothesis in this case? So, my research hypothesis is employees in managerial category are paid more salary in comparison to employees in clerical category. Now, I'll convert this research hypothesis into the statistical hypothesis. There is no significant difference in mean salary according to the employment category. Alternatively, there is a significant difference in mean salary in at least one pair of job category. I again repeat, one pair, which I have already explained to you, this one. The difference can be in any one pair. Okay. In some books, it is also written as mu1 is equal to mu2 is equal to mu3. Means means of all the three groups are equal. Alternatively, they are not equal. Alternatively, alternative hypothesis in some books is also written as mu1 minus mu2 is not equal to mu1 minus mu3 is not equal to mu2 minus mu3 is not equal to 0. Now, running which test, right? Either a Fisher's ANOVA or Welch ANOVA will completely depend upon the variances. This one, it will completely depend on homogeneity of variance. So, you should go in ANOVA. There are two things, or rather, there are two types of ANOVA, one-way ANOVA and the second is only ANOVA. Click on one-way ANOVA. Now, transfer salary in the dependent variable. So, it's quite clear that you can run ANOVA when you are having one continuous variable, scale variable, and one the grouping variable is in category. So I'll transfer job category here. Now to run the Fisher's ANOVA, this ANOVA or this ANOVA completely depends upon the homogeneity test. So click on the homogeneity test and you have got the result. Here it is 0.001. Now this means that as the p-value is less than 0.05, okay, I'll copy this result and I'll try to explain. My null hypothesis is variances of all groups are equal. My alternative is variances of all groups are not equal. When I have copied this result, I have deliberately changed this figure from 0.001 to 0.754 to make you understand that when we'll be running the Fisher's ANOVA. I'll again repeat, please be with me. See, this figure is 0.001. In the first scenario, I'll make it more than 0.05, and in second scenario, we will discuss when it is less than 0.001 what to do. So I've deliberately changed this figure to the higher side, that is more than 0.05. Now, what will be my interpretation? As the p-value of the homogeneity of the variance is 0.754, which is more than 5% level of significance, we fail to reject null hypothesis, which means that the variances of all groups are equal. First scenario, equal variances. So we can run ANOVA, that is a Fisher's ANOVA. So I'll go here, and as my variances are equal, I'll click on assume equal variances, and the interpretation will be from Fisher's ANOVA. Again, I'll right click it, copy it, and I'll bring it here. Now, as the p-value of the f-test is 0.00, which is less than 5% level of significance, so we reject null hypothesis, which means that there is significant difference in mean salary in at least one pair of job category. As the difference is significant, we will have to run the post hoc Tukey's test. See, we have assumed that the variances are equal, so it's yes, p-value more than 0.05, we are running Fisher's ANOVA, and its post hoc is Tukey's test. So from where I can run that, I'll go in post hoc and activate the Tukey, which is for equal variances. Click on it. I got the result. Now I'll again copy this result in the Word file and let us do the interpretation. Now here, clerical, when compared with custodial, its mean difference is given and its p-value is given here. Similarly, clerical compared with managerial, its mean difference and its p-value. Custodial compared with managerial and its p-value. Let me change this. Okay. Now how will write the interpretation? As the p-value of pair, clerical and custodial is 0.277, which is more than 5% level of significance. So we fail to reject null hypothesis, which means that there is no significant difference in mean salary of clerical and custodial. Now let us talk about clerical and managerial. As the p-value of clerical and managerial is 0.001, which is less than 5% level of significance. So we reject null hypothesis, which means that there is a significant difference in the mean salary of clerical and managerial. You can also generate the means plot. You can click on descriptive plots here and it will give you the means plot. You can see here the difference between clerical and managerial. The mean is quite significant. Similarly, the difference between the custodial and the managerial, the mean is quite significant. The mean difference is quite significant. Now, let us talk about the second scenario when the variances are not equal, our actual scenario. So, let us go back and talk about this table from where we started. As the p-value is not is less than 0.01, what will be our interpretation? Our null hypothesis is variances of all groups are equal. Alternatively, variances of all groups are not equal. Again, the interpretation will come from this p-value, which we had changed in earlier case to make you understand that in which scenario we'll be running the Fisher's ANOVA. Now here, as the p-value of the homogeneity of variance is 0.00, which is less than 5% level of significance, we reject null hypothesis, which means that the variances of all groups are not equal. So we cannot run the Fisher's ANOVA and we'll be running the Welch ANOVA. See this flowchart. p-value less than 0.05, variances are not equal, and therefore we will be running the Welch test. Okay, let's go here and remove the stick from here and don't assume equal variances. And now I'll get one way ANOVA Welch test. I'll simply copy this result in the Word file. Now what will be my interpretation? As the p-value of the Welch test is 0.00, this one, which is less than 5% level of significance, so we reject null hypothesis, which means that there is a significant difference in mean salary in at least one pair of job category. As the difference is significant, we have to run the post-hoc Games-Howell test. So the Welch test pair is with Games-Howell, and ANOVA, that is a Fisher's ANOVA, is having a pair with Tukey's test. Now I'll go in the post-hoc and I'll activate the Games-Howell unequal variances test. Again, I'll copy this result in the Word file. So this is the result which we have got. Now, quite surprising thing which has happened is the p-value of clerical with custodial. Now, what you will write as the p-value of the pair clerical to the custodial is 0.001, which is less than 5% level of significance. So we reject null hypothesis, which means that there is a significant difference in the mean salary of clerical and custodial. Similarly, if we talk about clerical with managerial, as a p-value of pair clerical to the managerial is 0.00, which is less than 5% level of significance. So we reject null hypothesis, which means that there is a significant difference in mean salary of clerical and managerial. Now, as the difference is large, we require the group descriptives. So this I can get from additional statistics. Click on descriptive tables and I'll get group descriptives. This one. I'll get the mean of clerical, custodial, and managerial. Now, what will be my interpretation? The mean salary of the clerical is $27,838. Mean salary of custodial is $30,938, and that of manager is $6,397. So managers are paid more salary in comparison to clerical and custodial. So for more videos on Jamovi, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please see my playlist in which I already uploaded many videos on Jamovi. Please don't forget to subscribe the channel and press the like button.